This is Chen Zhao from University of Southern California. Today I'm going to present our work on developing case-based weighted image average termed KWIA for ASL-based dynamic MRA and perfusion imaging. I have nothing to declare. In ASL, the difference between control and label images produces the perfusion image or non-contrast enhanced DMRA image. There is a delay time after labeling. If we image at multiple delay times, we can expand the data to 4D, so that's ASL-based 4D NCE DMRA and multi-delay ASL. The advantages of ASL-based 4D DMRA and multi-delay ASL are that they are non-invasive. Multiple quantification maps can be estimated simultaneously, and they enable the visualization of flow dynamics. However, their inherently low SNR becomes the biggest issue. Therefore, in this study, we aim to develop a denoising algorithm that improves SNR up to twofold without compromising spatial and temporal resolution, as well as quantification accuracy. Here I will introduce the KWIA algorithm using the 3-rings configuration. When we apply KWIA to a time series, a symmetric moving averaging window slides from the beginning to the end of the time series. When it stops, the time frame at the center of KWIA window will be denoised. First, we take FFT to get the original case bases. They will be weighted by the designed KWIA weighting functions. Then, by adding them together, we can get the KWIA denoised case base, where the central region purely comes from the selected frame, where outer rings are progressively averaged between neighboring time frames. The denoised image of the selected frame can be recovered using IFFT. So the motivations of such design are that the image contrast is primarily determined by the central case space, while averaging in outer case space improves SNR. We can theoretically predict the SNR improvement of KWIA. It increases with a greater number of rings and a smaller radius of the central region.
A digital phantom was simulated to test the SNR improvement of KWIA. It has 15 time frames. Gaussian noise was added in the case space. Gray and white matter regions and 3 DMRA vessels with different sizes were inserted. Associated signals were simulated.
So we conducted MR experiments for DMRA and multi-delay ASL. Here are some imaging parameters. For DMRA, there are 12 time frames and partial Fourier and grappa were applied. For ASL, there are 15 time frames. No additional MR conditions were applied. And this table shows the KWIA configurations used in our simulation and in vivo experiments. KWIA was designed to achieve 1.7-fold SNR improvement for DMRA and 2-fold for ASL.
We simulated 7 MR conditions on the digital phantom with KWIA processing. This table compares the measured to the expected ratios under these MR conditions. All of them match well except for the low-pass filtering and zero filling conditions. This figure presents the temporal error caused by KWIA in our simulation study. For DMRA, large and medium vessels were not severely affected with 1.7-fold SNR improvement, while there is about 5% error in small vessel. For the ASL, almost no errors were caused in gray and white matter signals.
This figure compares the original and KWIA processed 5 consecutive time frames of DMRA MIP images. Some distal small vessels, as indicated by the red arrows, are revealed by the KWIA because of the improved SNR. This figure compares the original and KWIA processed 15 delay perfusion images. KWIA significantly improved the image quality and visualization of dynamic perfusion signals. No notable spatial and temporal smoothing were introduced. These figures show the great consistency between the measured SNR improvement in our DMRA and ASL in vivo experiments to the theoretical prediction. These figures compare the signal curves between KWIA processed to the original. For DMRA, there is a 5% small signal drop at the peak of AF signal, while the gray and white matter signals of ASL were not obviously affected by KWIA. This result suggests KWIA produces negligible temporal error. All quantification maps of both DMRA and ASL were not adversely affected by KWIA. It's worth to mention that in DMRA, there is more distal small vessel structures shown in KWIA, and in ASL, the fitting residue is lower for KWIA. In conclusion, KWIA can improve SNR of ASL-based DMRA and multi-delay ASL by 1.7-fold and 2-fold respectively. The performance of KWIA is robust under various MR conditions. It does not cause notable temporal error or loss of spatial and temporal resolution. It does not affect quantification accuracy. It is computationally simple and fast. This concludes my presentation. Thanks for your attention.